Welcome to our exploration of inheritance in object-oriented programming. In this video, we'll delve into the concept of inheritance, a cornerstone of OOP that allows you to create new classes based on existing ones. We'll begin by defining inheritance and its purpose, highlighting how it promotes code reuse and a hierarchical class structure. Then, we'll explore the different types of inheritance and how base classes serve as templates for derived classes. We'll also cover method overriding, showing how derived classes can modify or extend the behavior of inherited methods. Finally, we'll look at the super keyword and its role in accessing superclass methods and constructors. Ready to understand how inheritance can streamline and enhance your programming? Let's dive in. Inheritance is a fundamental concept in object-oriented programming that allows one class, known as the subclass, to inherit fields and methods from another class, called the superclass. This mechanism promotes code reuse by enabling subclasses to leverage existing code, thereby reducing redundancy and simplifying maintenance. It also supports extendability, allowing developers to modify or extend classes without rewriting code, which enhances flexibility. Additionally, inheritance helps organize related classes into a hierarchical structure, making code management more intuitive. A real-world analogy is a car class that inherits common properties from a vehicle class, demonstrating how inheritance mirrors relationships in the real world and facilitates a more structured approach to programming. Inheritance in Java comes in several types, each serving a distinct purpose. In Java, single inheritance allows a class to inherit from only one class and the derived class, creating a clear and straightforward hierarchy. Also known as the multi-level inheritance enables a subclass to inherit from another subclass, forming a chain that can represent more complex relationships. The class that inherits from the inheritance occurs when multiple subclasses derive from the same uses the extends keyword, facilitating code reuse while allowing for specialization in each subclass. For example, however, Java does not support multiple inheritance directly to avoid the diamond common properties like where name ambiguity can arise from a class inheriting from two classes with the same derived class that inherits these properties. Java employs showcasing how inheritance which allow a class to implement multiple interface-related classes, providing flexibility and promoting a clean overriding without inheritance allows multiple class to provide a specific implementation of a method that is already defined in its superclass, enabling greater flexibility and customization. In Java, the @override annotation plays a crucial role by indicating that a method is intended to override a superclass method, which helps prevent errors and enhances code clarity. This mechanism offers significant benefits, as it allows subclasses to customize or extend the behavior of inherited methods to meet their specific needs. For instance, you might create a speak method in an animal class and then override it in dog and cat subclasses to provide unique behaviors, demonstrating how method overriding enables more specialized and relevant functionality in derived classes. The super keyword in Java serves an essential purpose in inheritance by allowing subclasses to access superclass methods and constructors, which fosters a clear relationship between the two. When a subclass needs to call a superclass constructor, using super helps avoid duplication in the subclass's structure by initializing inherited fields directly. For instance, you can demonstrate its functionality by using super to call a method like displayDetails from a superclass within a subclass. This not only showcases how subclasses can leverage existing functionality but also emphasizes the importance of maintaining a clean and efficient code structure through inheritance. As we conclude our journey through the concept of inheritance, we've laid the groundwork for understanding one of the cornerstones of object-oriented programming. We started by defining inheritance and exploring its purpose in promoting code reuse and creating hierarchical relationships between classes. Covered the various types of inheritance, understanding how they impact class design and structure. With a clear grasp of base and derived classes, we then delved into method overriding, which allows subclasses to provide specific implementations for inherited methods. Finally, examine the super keyword, a crucial tool for accessing parent class members and constructors. Armed with these insights, you're now ready to harness the power of inheritance to build more organized and efficient code. Embrace inheritance as a tool to streamline development and foster a logic class hierarchy in your projects. Happy coding, and may your use of inheritance always lead to elegant and reusable designs.